Alright, so I think this is recording. Let's take a look at this Skill 5D Day 2. We're focusing here on logarithmic functions and properties of log functions. I've went ahead and copied and pasted all of these problems from this worksheet, and in each and every problem the range is going to be all real numbers. So I went ahead and pasted that answer on all of these problems. So let's answer these other questions and then make a quick sketch of the graph. To determine the domain of the function, let's take this argument and set it equal to 0 and solve for x. So this is a two-step equation. Subtract 12 and divide by 2, and x is negative 6. There's no reflection across the y-axis. So the domain for this function is negative 6 to positive infinity. The vertical asymptote. Asymptotes are always an equation of a line. Vertical asymptotes are vertical lines, so the equation will be x equals, and it's x equals this negative 6. To find the x-intercept, you let y equal 0, and we solve this equation for x. So add 1 to each side, and then convert this log form to exponential form. So this base is 6. The exponent on 6 is the logarithm equals the exponent, so this exponent is 1. So this is a two-step equation. Subtract 12 and divide by 2. 6 minus 12 is a negative 6. Just trying to get more room here. 6 minus 12 is a negative 6, and then half of negative 6 is negative 3. Or you could write it as an ordered pair, negative 3 comma 0 for the x-intercept. So let's make a quick sketch then. And this is going to be a terrible sketch, but it's not asking for a graph. The vertical asymptote is x equals negative 6. So somewhere over here to the left of the origin, x equals negative 6. The x-intercept is negative 3, 0, so half that distance. The graph gets closer and closer to the vertical asymptote without touching, and then it increases like that. So there's my rough sketch for problem number 1. Let's go ahead and do problem number 2 on the same video. The range of any log function is all real numbers. Let's find the domain. Let's take the argument 4x minus 1, set it equal to 0 and solve. That's a two-step equation. Add 1 and divide by 4. There's no reflection across the y-axis, so the domain for this function is 1/4 to positive infinity. The vertical asymptote is the line x equals 1/4, and the x-intercept will let y equals 0 and solve for x. So subtract 2 from each side. Convert this equation that's in log form to exponential form. So the base is 3. The logarithm equals the exponent, so the base 3 has an exponent of negative 2. A negative exponent never makes your answer negative. It just changes the location of that base within a fraction. 3 to the negative second power is equal to 1/9. So this is a two-step equation. Add 1 and divide by 4. If I add 1, that'll be 10 over 9. And if I divide by 4, that'll be 10 over 36. But those are both even numbers, so that reduces to 5 over 18. or you could write it as an ordered pair. 5 over 18 comma 0 is the x-intercept. So the vertical asymptote is 1/4, so it's kind of close to the y-axis. Um, 9 over 18 is 1/2, so this is less than 1/2. Let's look at the decimal number. 5 over 18. 0.3, 1/4 is 0.25, so this is right next to that, and it's increasing like that. It's coming down and getting closer and closer to that vertical asymptote without touching. This is the x-axis, this is the y-axis. So that's just a rough sketch of my graph. I'm going to keep going. The range of any log function is all real numbers. To find the domain, let's take the argument and set it equal to 0 and solve. That's a two-step equation. Add 1 and divide by 3. So my domain, this 1/3 tells me my domain and my vertical asymptote. Since there's no reflection across the y-axis, it's 1/3 comma infinity, and the vertical asymptote is the line, and it's the vertical line, x equals 1/3. Now let's find the x-intercept by letting y equal 0. Solving this equation for x, let's subtract 4 from each side. Convert this equation that's in log form to exponential form. The base is 2, the exponent is -4. Negative exponent never makes your answer negative, it just changes the location of the base within a fraction. Oops. So this is equal to 3x minus 1. So now we have a two-step equation, add 1 and divide by 3. So this is 1/16. And if we add 1, that'll be 17 over 16. And if we divide by 3, that'll be 17 over 48. So that doesn't reduce. Let's look at what that decimal number is. 17 divided by 48, 0.4 say. And so if we make a quick sketch of the graph, vertical asymptote of 1/3, well, that's not that far from the y-axis. And this x-intercept is pretty close to it, and your graph gets closer and closer to the x-intercept without touching it, and it's going like that. So there's a very rough sketch of our graph. I'm going to do number 4 on this same video. We'll do 4 problems on a video. The range of any logarithmic function is all real numbers. To find the domain, let's take this argument 4x minus 12 and set it equal to 0. That's a two-step equation. Add 12 and divide by 4. So this x equals 3. This 3 gives me my domain and my vertical asymptote. Vertical asymptote is the line x equals 3. Since there's no negative sign in front of x, there's been no reflection across the y-axis, so this domain is from 3 to infinity. And now to find the x-intercept, you let y equal 0. So to solve this log equation, we get the term that contains our variable by itself, so we add 2 to each side. And then there's not really anything that we can do to get x by itself here, because this does not mean log times this binomial. So this equation is in what they refer to as a log form, and we can convert this to exponential form and then solve it. We'll have a lot better luck at solving this in exponential form. The base is 6. The exponent on 6, well, the log equals the exponent, so it's 2. So then this is a two-step equation, add 12 and divide by 4. So 6 squared is 36. 36 plus 12 is 48. 48 divided by 4 is 12. So I'm getting that x is equal to 12. Let's check that real quick. 4 times 12, yeah, it should check. Yeah, okay. Let's make a quick, people might present that x-intercept as an ordered pair. Here's the y-axis, the x-axis, x equals 3, I don't know, say it's right there. The line x equals 3. 12, quite a bit over. So I know that's kind of a curve. It looks like a line. The graph gets closer and closer to that vertical asymptote without ever touching it. If we wanted a more accurate graph, we could make a table and plot more points, but the emphasis here is just on the properties and a quick sketch, and just to understand the general shape of the graph, or at least that's how I think that you should practice and stuff right now. If they wanted a really, really detailed graph in today's world, we would just use technology and jump to that Desmos graphing calculator and have a computer graph it and then print out that graph. Because if we need to actually read coordinates or use the graph for explicit detail of this function, like I say, we may as well use technology. All right, I hope that helps. I'll talk to you later. Bye.